Hey there, Algebra 1 students. I want to talk to you today about even and odd functions and vertex form of quadratic equations so that we can graph these parabolas. All right, an even function, it is symmetric about the y-axis. And if you plug in negative x for x into the original function, you end up with the original function, f of x. An odd function, when you plug in a negative x into the original function and you simplify it and work it through, you end up with the opposite of the original function, meaning the sign has changed for everything in that equation. Odd functions are also symmetric about the origin. So let's consider a couple examples here. Let's look at this guy here. F of x is 5x. If we wanted to figure out whether or not this is odd or even, we plug in a negative x here, and we will replace this x with a negative x as well. When we multiply 5 by negative x, we can move that negative out in front, and so we would have negative 5x. Well, this is the same as negative f of x. And so because it's the opposite of what we originally started with, right, it is an odd function. Let's consider this guy here. F of x equals negative 4x squared. If we plug in a negative x for x, right, and then we square it, when we square a negative number, we get a positive number, right? So this guy becomes a positive, but this negative 4 is still negative. So it's negative 4x squared, which is what we originally started with, right? That's the same thing. And so it's equal to f of x. And so because f of negative x equals f of x, it is an even function. Let's talk now about vertex form of a quadratic equation. Vertex form looks like this. F of x equals a times x minus h squared plus k. And your vertex is given by h and k, all right? And then your axis of symmetry is x equals h. That's it. So let's try a couple examples here. Suppose you have f of x equals 5 times x minus 2, the quantity squared. Your vertex is just 2, 0. All right, this graph has been shifted 2 units to the right and vertically stretched by a factor of 5. But the vertex is at the point 2, 0. And so your axis of symmetry is x equals 2, which is the x value for your vertex, right? Let's say you have p of x equals negative 1/2 times the quantity x minus 1 squared plus 4. The h is 1, k is the 4, and so your vertex is just 1, 4. And your axis of symmetry is x equals 1, because that's the x coordinate of your vertex. All right? And one last problem. Suppose we have m of x equals 3 times the quantity x plus 2 squared, and they ask you to graph the function and compare it to the graph of x squared, the graph of x squared. So, well, where's my vertex? My vertex is at the point 2, that's a negative 2, 0. So negative 2, 0, there's my vertex. This 3 means there's a vertical stretch by a factor of 3. And so a normal parabola goes up by 1, but in the first points away from the vertex, but this one has been stretched by 3, so it goes up by 3, and then it will continue to go up very fast because it's been a vertical stretch. So that is a very quick sketch of this parabola. And I'm going to also quickly sketch the graph of x squared, which is over here. Just like this. Okay, this is x squared. How do these two compare? M of x is a vertical stretch. By a factor of 3, because of the 3 in front of the x plus 2 squared, right? And a horizontal translation two units to the left. Horizontal translation, 2 units to the left. Okay, I hope that this helps you understand this lesson about vertex form and even and odd functions, and I hope that you're all well. We'll see you next time.